So for web work number 9, problem 13, we have to find the direction in which the function f is increasing the fastest at the point x equals 2, y equals 2. And then we have to find the rate of increase in that direction. And that's going to be where f of xy is equal to x cubed minus 2x times y squared. So what is the direction in which f is increasing the fastest at the point? Well, it's just going to be the gradient of the function as defined by the derivative with respect to x of xy and the derivative with respect to y of xy. And that should make sense that the derivative with respect to x is going to be in the I hat direction, and the derivative with respect to y is going to be in the j hat direction. So now we have to real quick decide whether or not we want a negative in front of the function. If you put the negative in front of the derivative, you have the path in the steepest descent, and without the negative, you have the path in the steepest ascent of the function. And in this case, we're looking for the direction in which f is increasing the fastest, and that's going to be the ascent of the function, and therefore we don't have to use the negative, which would go in front of the function. So what other parts do we need? Well, obviously we're going to have f of x, xy, so the derivative with respect to x, and that's fairly easy to find. It's going to be derivative with respect to x. That's just going to be equal to 3x squared minus 2y squared. Fairly easy to find. I mean, not a lot of explanation there. And then for the derivative with respect to y, it's just going to be, we don't have to worry about this, that's just equal to 0. It's going to be negative 4x y. So all we have to do now is throw this in the formula, and we arrive at the conclusion that f of xy is equal to 3x squared minus 2y squared I hat minus 4xy j hat, where that minus is coming from the negative. And so now all we have to do is evaluate this function for the values of x and y that we're given. So that's going to give us the gradient of xy is equal to 3 times 2 squared minus 2 times 2 squared, where y is equal to 2, x is equal to 2. That's I hat minus 4 times 2 times 2, whereas that is the j hat. And that is going to equal 12 minus 8. Which gives us 4 I hat minus 16 j hat. And that is the directional derivative, or rather the gradient of f of xy. And that's going to be evaluated at the point 2, 2. So now that we've found the gradient, which is the greatest, or rather the direction of the greatest increase in the function f of xy, we can find the rate of that increase, which is going to be equal to the slope of the gradient. Well, what is the slope of the gradient? Well, we found the slope of x and we found the slope of y. These are equal to these two values right here. So wouldn't it just make sense that if you take the magnitude of the gradient, you're going to end up with the slope of the gradient, which is going to be the rate of increase in that direction. So to find the magnitude, all we have to do is square both values under the square root. And that's going to be equal to 4 root 17, which is the rate of increase in the direction of the gradient. And we're done.